All right, you guys, we're going to start lesson 3.3. This is going to be really fun. We're going to draw the graphs from an original graph. We're going to graph a derivative, and from a derivative, we're going to go backwards and graph the graph. So this is going to be using our knowledge about what derivative is and what second derivative means to an actual graph, okay? So the first thing that you need to learn is if I'm going forwards, so if I'm going from an f graph, which is your function, to a derivative, or if I'm going from a first derivative to a second derivative, then all I'm going to do is find slopes at a specific value, okay? So for this right here, I have an x value of negative 3.5. So at negative 3.5, I'm going to estimate what this slope is right here, okay? So if I went up here to find this slope, I would go up 1 and over a half, okay? So if I go up 1 and over 1/2, then that makes the slope approximately 2. Okay, so there's going to be a point on the graph, negative 3.52. So I'm going to go over to negative 3.5 and up 2. And that's going to be my starting point, okay? So all I did was find this slope right here. First of all, anytime you have a max or a min, you know the slope is 0. So negative 2 is going to be 0. I'm going to mark that right here. And then positive 2 is going to be 0. And then 3.5 is going to be down 1 and over a half to the left. So that's also going to be 2. So 3.52, okay? The only thing I need to figure out is right here in the middle at 0. So what is this slope right here, approximately? So I could look at this and I could say, okay, I'm going down 2 and over 2. So down and to the right is going to be negative 1. So at 0, it's negative 1. 0, negative 1's right here. And then I just connect the dots. Okay, so quite honestly, it is easier going from a graph to the derivative because you just have to find specific slopes. You don't have to go through your f prime number line and your f double prime number line, which is what we're going to do next. Okay, so down here at the bottom, this tells you how to do an antiderivative, which means I'm going backwards. Okay, so an antiderivative means I have the derivative and I want to go backwards to the function itself. So I'm going to do two things. I'm going to make an f prime number line. This is going to be using the location of the position of the points, okay? So what that means is if the graph of f prime is above the x-axis, then I would put a plus sign. If the graph of f prime is below the x-axis, then you put a minus sign. Okay, so you know that this equates to where the original graph is increasing and decreasing. Okay, so if f prime is above the x-axis, it's increasing. So I could look at this graph and say, okay, this f prime graph is above between negative 3.5 and negative 2. So between negative 3.5 and negative 2, my graph is increasing, and that's true. Okay. And then from 2 all the way to 2, so between negative 2 and 2, it's below the x-axis, so that's negative. And then you notice this is decreasing between negative 2 and 2. Okay, and then from 2 to 3.5 is above again, and that's where it's increasing again. So you could kind of see how those two graphs relate. Now, the one thing that it doesn't tell you is where this maximum occurs. So I know that at negative 2, the f prime was 0, so that's a max or a min on the graph, okay? But I don't know that the max is negative 2 and then 1. I just know it's a max. Hope that makes sense. So over here, I know that there's a min at 2. And I would have to figure out max and mins by doing second derivatives. But we have the original graph, so you can tell it's a min. So right here, I've got this 2 is 0, and so that means it was a max or a min, and I don't know what the y value is, though. I just know a max or a min occurred, okay? All right, so then the second thing that you're going to do is make an f double prime number line, and this is using the slopes of the graphs, just like we did here. So anytime I go from 1 and then move forward an extra derivative, I'm always going to use the slopes and plot points. Now, if I only had an f prime graph, I could look and say, okay, well, my f prime graph is decreasing, right? So I could say where it's decreasing and then where it's increasing for the slope. So if I did an f double prime graph, I would have a decreasing slope here. So that would be, I just lost my train of thought. So I'm going down right here. So that would be concave. You know what I'm saying? We go from this f double prime tells us when it's concave up and concave down. Okay, we'll get to that when we get to an actual graph. So right here, this is saying, so we combine this information and we plot the points. If there's no starting point given, then you can shift the graph wherever you want. Okay, real quick, I'm going to make sure that I'm recording. I am, so we are good to go. Okay, so let's turn the page over and go backwards. Okay, so on this graph, on example 2, let's see if we can get this to focus a little bit better. Maybe a little. Okay, so on example 2, we are going to have an f prime graph. So I know the derivative, and I'm going to draw the function. Okay, so right here, for the f prime graph, I want to know where it's above and where it's below. So right here, the graph starts at negative 3.5, and at negative 3.5 until 0, it's above the x-axis. So I would do a positive sign, okay? And then from the 3.5, so here from 0 until 3.5 on this side, it's below the x-axis, so that's going to be a negative. Okay, so now I still know I'm going to be starting my second derivative at negative 3.5, but for my second derivative, I'm looking at the slope of the first derivative. So let me write that down up here. So for second derivative, you look at the slope of the first derivative. Okay, so the slope is increasing until negative 2. So my second derivative is going to have an increasing slope until negative 2, so that's going to be a positive. Okay, then between negative 2 and positive 2, this is decreasing, so that's going to be a negative, and then from 2 to 3.5, it's increasing again. So that's what I meant on the other side when you know it's decreasing, then you know it's negative, which means concave down, right? So when the second derivative is negative, I know my original graph is concave down. And right here, I know it was concave up. So I know my graph's going to start concave up, okay? And then it's going to switch and be concave down between negative 2 and 2. And then it's going to be concave up at the end again. I know that right here, this is increasing and then decreasing. So I'm going to have a max at 0. And I don't know what the y value is of that maximum, except for it gave it to you right here. So I know that this max is 0, 1. Okay, so 0, 1 is going to be a maximum. And then I know at negative 2 and 2, it's concave down. So it's going to look like this. Something like this. and doesn't have to match exactly. It just has to follow the rule. At -2, it's an inflection point. Okay, so right here and right here, it's going to change from concave up to concave down. So 3.5, so somewhere at 3.5, this graph's going to stop. I don't know exactly where that point is. I just know that it stops there, okay? So I know right here it's concave up, then it's switched to concave down, and now it's going to go back to concave up like this. Okay? So I knew that from here to here, so from -3.5 to 0, it's increasing. And from 0 to 3.5, it's decreasing. And I knew there was a max at 0, 1. Okay. All right, let's do the next one, example 3. So this time they start off by giving us the first derivative, but then we have to find the second derivative and f. So let's start by doing f prime to f double prime. So I'm going to find the slope at specific points. I notice that this is a straight line. So from -infinity until 0, there is a straight line, and I just need to find the slope of that straight line. Okay, so up 2 over 2, so the slope is 1. So anywhere between -infinity and 0, m is equal to 1. So that's just going to look like this. Okay, I'm going to do an open circle here because I can see that there's a jump going on right here, or a place where the derivative from f prime to f double prime is not going to exist because of this sharp turn. But that's not necessarily over here. There's probably a smooth curve here. Okay, so now I'm looking at my second half of my graph, and I notice that this is concave up. Okay, so I'm going to look at this and I'm going to say, okay, well, there's a minimum right here. And so we know that the slope was 0 at the minimum, right? So at this point, 0 is 0, 0. So this is going to start at 0, 0. And then if I do this slope between here to here, you get a 1. But if you go to here, you're going 2 divided by 3/2. So you can kind of see that this slope is a little steeper than 1. And if I know that this is x squared, then I know the slope of that is 2x. So I'm looking at a graph that is 2x that looks like this. Okay, it's a straight line as well. So this one that was linear turned to be a constant, and this one that was a parabola or quadratic turned to be linear. Okay, so that's going backwards. Now, if I look over here at f prime, I'm just going to say, where is it positive, where is it negative? So at -2 is where it changes. So it's below until -2, and then it's above everywhere after that. Okay. I am going to put a little stopping point at 0 because of the sharp turn right there. Okay, so I'm going to put a little spot right there so I can remember that there's a sharp turn at 0, which isn't really going to matter because that's not going to affect this graph. It would affect it going backwards. Okay, and then f double prime, I'm looking to see if it's increasing or decreasing. So if I look at this graph, it's increasing and then it's still increasing. So f double prime is always increasing, which means our function is always concave up. Okay, but I know that right here, there's a sharp turn. Okay, so that's how I knew that this was a jump, was because of that sharp turn. Okay, at -2, my derivative was 0. Anywhere your derivative is 0 is a max or a min. Okay, so the x-intercepts on f prime are a max or min on f. These are little notes that you're going to want to put that will help you when you're graphing these. This is a more challenging section for sure. Okay, so x-intercepts on f prime are max or min. So I know there's a max or a min at -2, and I know this is concave up. So the only way that can be a max or a min and be concave up is if it looks like this, right? So somewhere at -2, it's going to come down, and then it's going to be a minimum at -2, and then it's going to go up like this. That follows the negative and the positive for our slopes. Okay, so negative slope, positive slope. It follows concavity, concave up, and then going backwards, I have my jump. So this is what you do on these. You have to just analyze it one little thing at a time. You cannot rush it. And you just go through those steps. Okay? All right, let me know if you have any questions.